You write a scraper, it seems to be running fine, and then the moment you point it at a real website, it breaks. The page comes back empty, requests get interrupted, or you hit a CAPTCHA on the first try. Hi, my name is Manfredas, and in this video, I'll show you how to handle that with Puppeteer, the Node.js library that drives a real browser, and what to do once websites start acting up on your scraper. We'll set up a project from scratch, automate a browser, scrape a JavaScript rendered page, save the results to JSON, and finally, cover the options for scaling when target sites push back. Ready? So, Puppeteer is an open-source Node.js library created by the Chrome team that lets you control Chrome from code. Anything you do in a browser by hand, like clicking through pages, scrolling, filling out forms, waiting for content to render, you can also do through Puppeteer. That makes it a great fit for three things: web scraping on modern JavaScript-heavy sites, browser automation like form submission and multi-step navigation flows, and end-to-end testing. Since Puppeteer is a JavaScript library, to run it outside the browser, we need Node.js. Node executes our scripts, and it also gives us npm, the package manager we'll use to install Puppeteer in a moment. Compared to a traditional scraper that uses a plain HTTP client like Axios, Puppeteer works differently. Axios downloads the raw HTML and stops. If the data only appears after JavaScript runs, the client never sees it. Puppeteer, on the other hand, loads the page in a real browser, lets the JavaScript finish, then reads the fully rendered result, the same way you would in your browser. Before we install anything, let's make sure Node.js is ready to go. We check the Node and npm versions in the terminal. If either command fails, head over to nodejs.org and install the LTS version. Next, we create a fresh project folder, move into it, and initialize a new Node project with npm init-y. That command creates a package.json with default values so we can start installing dependencies right away. Then we install Puppeteer with npm install Puppeteer. This single command pulls in the library and also downloads a matching version of Chromium that Puppeteer will drive. It takes a few seconds, but once it's done, we're fully set up. No extra browser drivers, no separate downloads. Quick look at what we have now. There's a package.json with our dependencies, a node_modules folder where Puppeteer and Chromium are saved, and from here on, we'll add a single scraper.js file at the root. That's the whole project layout. Let's start with the simplest possible Puppeteer script. Open a browser, visit a page, take a screenshot, and clean up after itself. We create a new file called scraper.js and open it in VS Code. At the top, we import Puppeteer. Then we wrap everything in an async function that we define and call immediately on the same line. That lets us use await inside without any extra setup. Inside, we call puppeteer.launch to start a browser instance, then browser.newPage to open a fresh tab. We point that page at quotes.toscrape.com/js, which is a demo site that loads its content with JavaScript. With the page open, we call page.screenshot, passing a file path and full page set to true so we capture the entire page, not just the visible viewport. Finally, browser.close releases the resources. Make sure to always close the browser, otherwise you'll leak Chrome processes in the background. In production, you'd wrap this in a try finally to ensure it closes even on a thrown error, but for this demo, calling it directly is fine. Now, time to run it. Back in the terminal, we run nodescraper.js. After a second, the script exits and a new file, quotes.png, appears in the folder. Opening it, we can see Puppeteer loaded the JavaScript rendered page and captured the rendered quotes. A screenshot is nice, but if you want to go a step further, structured data is what you should be after. So why don't we open the page in the browser and inspect the HTML? Each quote sits inside a div with class quote, and inside it we have a span class equals dark red with class text, a small element with class author, and several anchors with class tag. Those four selectors are all we need. For each anchor, we'll pull the visible text, but you could grab attributes like href the same way if you needed the link. Back in the script, we keep the navigation step, but swap the screenshot for real extraction. We also add fs at the top. That's Node's file system module, and we'll use it at the end to save our results. Right after page.goto, we call page.waitForSelector with the quote selector. This is the standard Puppeteer pattern for dynamic sites. We don't move on until the JavaScript has finished rendering the content we need. Then we call page.evaluate. It runs a function inside the browser context with access to the page's DOM. Inside, we select every element matching .quote, map each one to a plain object with text, author, and tags, then return the resulting array. Back in Node, that array becomes our quotes variable. We write it to quotes.json with 2-space indentation so the file stays readable. Log how many quotes we extracted and close the browser. We're using the synchronous write here to keep the example short, but in production, you'd use fs.promises.write file to fit the async function. Let's run it. We execute nodescraper.js again. This time, the script logs the number of quotes saved, and the new quotes.json file contains structured data, with each entry holding its text, author, and tags. The script we just built already handles one common production challenge. WaitForSelector handles content that's rendered by JavaScript after the page loads. But sites do more than just delay load. They paginate, they hide content behind scroll triggers, and they actively look out for automated traffic. We can take a look at how to handle each. Two of the most common patterns are pagination and infinite scroll. Here's pagination running against a local test page. The script reads the quotes, clicks next, waits for the new content, and repeats until there's nothing left. Infinite scroll is similar, but driven by the scroll position. The script calls page.evaluate to scroll the window down, then waits for new elements to render. The API calls are short, but in practice, both patterns need wait logic, retry handling, and break conditions for when to stop, so the full implementation usually grows beyond the snippet. Once you're hitting those patterns at scale, the bigger problem isn't the page anymore, it's the site noticing you. You may run into rate limits, browser fingerprinting checks, CAPTCHAs, and other IP restrictions. From the site's perspective, Puppeteer running on a single machine looks like a user sending many requests from the same IP. The standard fix is to distribute that traffic across a pool of residential IPs. This way, traffic patterns remain more consistent with standard browsing activity, helping maintain reliable access at scale. But if you want to skip proxy management, browser maintenance, and setup complexity altogether, you can use an all-in-one solution like the Oxylabs Web Scraper API. Instead of writing complex Puppeteer navigation logic, you send an API request pointing at your target URL. The render parameter alone replaces the browser launch, WaitForSelector, and session management we just wrote, and retries and request management happen server-side, automatically. Those are two of the biggest challenges when scraping complex pages. Here's the script running. The response comes back with the rendered HTML for the page. There's also a free trial link for the Web Scraper API in the description if you'd like to test it on your own target. And that's the full Puppeteer scraper. We installed Puppeteer in a fresh Node project, launched Chromium, waited for the page to render, extracted structured data with page.evaluate, and saved it to JSON. From there, scaling up means either layering in residential proxies or skipping the Puppeteer plumbing entirely with the Web Scraper API. For more guidance on this and related topics, visit our blog. And if any questions arise along the way, you can reach our 24/7 team at support@oxylabs.io. Subscribe for more practical content like this, and thanks for watching.